Here's an example using the sampling distribution of sample mean probabilities with commute times. Suppose the commute times, x, for students at a college have a mean of mu equals 20 minutes and a standard deviation of sigma equals 6 minutes. Find the probability that x is less than 15. So what that means is, find the probability that if you randomly choose a student, so if you choose one student, what is the probability that their commute time is less than 15 minutes? So this goes back to what we've done before. So go back and study the normal curve probabilities. And you put 20 in the middle because that is your mean. 15 is going to be below that. And then x is less than 15, mean we're shading to the left because less than you shade left. So now, in order to find a probability, you have to convert x into z and then find probability in your tables or your calculator. Okay, so when you convert x into z, the formula that always does that is your z-score formula, z equals x minus mu over sigma. So x is 15, the mean is 20, divided by the standard deviation of 6. So you get a z-score of negative 0.83. So on the x-axis, we have a wait time of less than 15 minutes, corresponds to a z-score of less than negative 0.83. Okay, so the probability that z is less than negative 0.83, you can look that up in your table or in your calculator function to get 0.2033. So now what we're going to do is we're going to take a sample of 50 students. If we take a sample of 50 students, we're going to sketch a graph of the sampling distribution of sample means. And we're going to label the axes. Okay, so remember, the mean of the sample means is the same as the mean of the original, which is 20 minutes. Now the standard deviation is what changes. That depends on your sample size. So sigma sub x bar is sigma over the square root of n. So in this case, it's 6 over the square root of 50, which is approximately 0.85. So if we were to label that on our axes, we have the sample mean, x bar, and 20 is in the center because that's the mean of the sample means. And then just label one standard deviation above the mean, which is 20.85. 2 standard deviations above the mean is 21.7, and so on. Okay, so that is what the graph looks like for the sampling distribution of sample means. Okay, now we're going to find, in number 3, the probability that a sample mean is less than 18. So now what this is asking is, if you took a sample of 50 students, what is the probability that their mean time, that their average mean time would be less than 18? So now you graph your distribution for x bar. 20 is in the center. 18 is to the left of 20. And then x is less than 18, we're shading to the left, so less than 18. Now we need to convert x bar into z. And the way you do that, everything in your z formula, x minus mu over sigma, everything turns into x bars. So x turns into x bar, mu turns into mu sub x bar, and sigma turns into sigma sub x bar. The concept will be the same. You still put the numbers in the same place. Your sample mean minus the population mean. So that's 18 minus 20. Same ideas up here, 15 minus 20. Then you divide by the standard deviation, which is now 6 over the square root of 50. And when you put that in your calculator, make sure you put parentheses around 6 over the square root of 50 so it stays together. Do 18 minus 2 is negative 2, and then divide that answer by 6 over the square root of 50. And you should get negative 2.36. Okay, and I'll mention, I'm putting 6 over the square root of 50 in the calculator. I'm not putting the rounded value of 0.85, and that is just to avoid rounding errors in the z-score. Okay, so put the actual sigma over square root of n, whatever that is right here. Okay, don't round that, you round your z-score. Okay, so then, this just turns in now finding the probability that x bar is less than 18 equals the probability that z is less than negative 2.36. Okay, so you go through and do that, and there's your calculator function. Okay, and then the next one, I'll show you this quickly because hopefully you get the idea of it. Turn x bar into a z-score. Okay, so you get negative 1.18. So the probability that x bar is greater than 19 equals the probability that z is greater than negative 1.18. And you do the steps to find that. Again, the greater than negative 1.18, you have to do 1 minus, or your calculator function will give you the exact answer there, 0.8810. Okay, and then on the last page, find the probability that a mean commute time is between 18 and 21 minutes. So the probability that a mean commute time is between 18 and 21 minutes. Okay, so on our distribution, on our graph, it looks like this. Okay, in theory, I haven't found the z-values yet. Okay, but that's what it looks like on the x bar axis. Now we need to convert x bar into z. So we already did 18. We already did that and got negative 2.36. That was from the previous page. And then 21, if we convert that into a z-score, you get positive 1.18. Okay, and if you need to pause the video, go ahead. I'm just going to keep on going for the sake of time. So the probability that you are between, that z is between those two numbers, this is where you subtract the two probabilities. 0.8810 is what you get when you look up when you look up 1.18, you get 0.8810. When you look up negative 2.36, you get 0.0091. Subtract those, and that'll give you the answer. Okay, this is the calculator function that you use to get that. And I will say that when I grade these, I'm going to ask you to see the diagram, find the z-scores for each of these. So basically everything I have on here I want to see, not just the calculator function. I won't give you full credit if you just say normal CDF. Okay, I want to see the diagram and how you find the z-scores for those.